Let's combining all these together, we will get okay. In this situation, this is the AND gate operation, and we noticed the weight parameters as I already explained. Minus 30, we are considering the this value in order to considering the significance of these second and both the switches. Here the weight parameter is less in order to give the here this is the R operation, the negative 20. So make the sense of this is a little bit good. But in this negation case, again we are decreasing the weight value that is equivalent to 10. Okay, remember this. The reason is this: we are negating it. Once we are negating it, this negative 30, we will transform into some positive value. And these plus 20, though they both are the AND gate, but here in the case of binary, if the value is 1, after negating it, this 1 will be transformed into the 0. Here again, if we are considering it's 1, then after negation, this sign is telling us some kind of a negation symbol. Okay, so this is the negation, so this will give us the value equivalent to 0. Let me merge all in some big sector. First of all, now two possible activation function at this point. The first one, again we are dealing the two features, standard two features x1 and x2. So there are the 4 possible rows. So first activation functions, we will need to consider the weight here. So the weight parameter for this one, minus 30, 20, 20. So in this situation, what will happen if we are talking about the this first activation, this one. Again, the circuit systems, it's very simple. Both switches are off, we will get 0. If this is what series case, and as I told you about this circuit. If both are in off condition, of course 0. Even if one is connecting, another is disconnecting, again bulb will not glow. So again 0. If one is connecting, another is disconnecting, again 0. Bulb will glow only and only when both switches are connected, so it's 1. Here at this position, we are getting, so this is the second layer activation function, first activation function of the second layer. For this negation case, we are considering the second activation function of the second layer. So the pass here, let me take this. The weight, let's say here the 10, negative 20, negative 20 here. So we will substitute again, all these again in the sigmoid term of functions, and for simplicity I will calculate it as it is, and we can observe once there is a negation, x1 negation, then 0 will be transformed into 1, x2 negation, then it will again 1, then answer will, if this shows, because there is the AND gate. And in this case, if both are connecting, Of course, we will evaluate with the computing will evaluate with the help of sigmoid function input, but here we can understand it if both will be connected, because 0 will be transformed into 1, 0 will be transformed into 1 because there is a negation after 0, so both are 1, so both switches are on, this will give us 1. Again, this is a series circuit. If negation of 0 it's 1, negation of 1 is 0, so one switch is off, so answer is 0. Again, now if this one negation of 1 is 0, negation of 0 is 1, one switch is off, again we will get 0. Here, very interesting thing. We apply negation on this, though technically switches look like on because x1, x2 both are in on condition, but we apply negating it. This inversion, this formulae, so 1 will be transformed into the 0. So in this case, both are 0, it means switch is completely off, both switches are off, circuit is off, so bulb will not glow. Answer is what? 0. Now, the third output, this is our second layer. This one is the second layer. Now we need to proceed further. We need to merge for getting our final decision. Though these are some kind of a neural setup, as I told you that since we want to confirm something, though we are observing some flames, but with the help of visual we are observing, with the help of body temperature we are observing. Even we can listen some kind of auditory sounds of the flames. So many ways we are observing and we are cross confirming, and we say that there is a fire. So we may call to the firefighters, or there is some kind of a sign of a fire. So now in the second layer we have two possible testing sets. So we need to merge them together. For this purpose we are using the OR gate, because we are finally deciding that this is kind of a fire. Is it dangerous or not? So OR gate will work here. OR gate operation will be worked in this situation. So we need to determine the third layer activation function, because it's the finalizing stage. Only one activation function will decide. So here, of course, the biased, this one is the biased, plus one is some kind of a biased value. So plus 1, of course this is representing some kind of a this one, and of course the weight is given to this one is somehow, you can say, this R case we are considering negative weight here, so positive weight here, so again positive weight here. So we are merging all together, and this is the following some kind of a parallel circuit. For conclusion purpose, though this is the final output technically, and we say this is the equivalent to this one. As you can say, this activation third layer equivalent to all the activation of the second layer. So second layer activations, A is representing the second layer. Instead of X I am using this one. So we are getting these possible features value, and if this is this circuit, parallel circuit here. This parallel circuit, if both any one switch will be connect, then of course bulb will glow. So among here, if one switch in a parallel circuit, one switch is connecting, then of course bulb will glow. So we will write answer is 1. If both switches are in off condition, then bulb will not glow. If again both switch in off condition, bulb will not glow. If again the one switch is on in a parallel conditions, okay, here let me explain it again. So for example, this one is connecting, the above one is not connecting, then again bulb will glow. So it's 1. So our final output hypothesis is giving us some kind of a decision that if the situation input is both are the off, we will get this kind of activation function. Then there is a fire, dangerous fire. If this is situation, then fire is not in a dangerous mode. If this is a situation, fire is not in a dangerous mode. If this is a situation, fire is in a dangerous mode. So this is some kind of a situation, and we that this is the case +1, and this is the this is the benign, this is the benign, and this one is the +1, this one is the +1. So it is some kind of a dangerous thing. Fire is confirming in situation if we are dealing with this +1, if we are getting 0 0, so it's fine. If in any case we are getting +1, even we are not getting this one, but this single one is also enough.